will discuss about assignment operators in Verilog. Assignment operators play a crucial role in understanding how values are assigned to variables and signals in hardware description. Assignment operators can be four types. First one is continuous assignment, second one is blocking assignment, third one is non-blocking assignment, fourth one is delay assignment. Now I will discuss four types of assignment operators in details. First one is continuous assignment. Continuous assignment used for combinational logic. It used within assigned statements. It continuously drives a word with a value, updating whenever the value of the expression changes. The syntax of assignment operators starts with the keyword assign, then var name, then equal, then expression, then semicolon. For this example, we write assign sum equal a plus b. The identifier sum will always hold the summation of a and b. Next one is blocking assignment. Blocking assignment used inside the procedural block, such as initial or always block. These statements are executed sequentially. The next statement doesn't execute until the current statement completes. It means if the current statement doesn't execute, the next statement will not be executed. So for the execution of next statement, the current or present statement must have to be executed. The syntax of blocking assignment. First variable, then equal, then expression, then semicolon. In this example, inside the always block, we write two blocking statements. First one is a equal b plus c, second one is d equal a plus 1. For first statement, a is assigned the value of b plus c at the clock edge. For second statement, d is assigned based on the update value of a. Note that blocking statements should typically be used for combinational logic in always blocks. Next one is non-blocking assignment. Non-blocking assignment used inside the procedural block, such as initial and always. It allows for parallel execution of statements. It used for describing sequential logics. The syntax of non-blocking assignment is variable, then less than equal, then expression, then semicolon. In this example, inside the always block, we write two non-blocking statements. First one is a non-blocking b plus c. Second one is d non-blocking a plus 1. It means first statement updates a after the entire block is executed. In the second statement, d will get updated within the old value of a, not the new one. It means the execution of second statement doesn't depend on the execution of first statement. So the value of a in the second statement doesn't depend on the value of a on the first statement. Note that non-blocking assignment are used in clock logic to avoid race condition. Comparison of blocking and non-blocking assignment. Execution order for blocking assignment is sequential, for non-blocking assignment is parallel. Blocking assignment mostly used for combinational logic, non-blocking assignment mostly used for sequential logic. Here are some guidelines for using assignment operators. First one is use assign with continuous statement for driving combinational logic. Use blocking assignment for combinational procedural logic. Use non-blocking assignments for sequential logic with clock always blocks. Next one is delay assignment. Verilog delay assignment can have delay specified either on the left side or on the right side of the assignment operators. We can introduce delay before assigning a value or after assigning the value. Delay assignment mostly used in simulations. The syntax for delay assignment is has delay, then variable, then assign operator, then expression, then semicolon. In this example, inside the initial block, we write has 5, a is equal to 1. It means assign 1 to a after 5 time units. Delay assignment can be two types. First one is inter-assignment delay. Second one is intra-assignment delays. For inter-assignment delays, delay is specified on the left hand side. The syntax for this delays has delay, then left hand side then equal, then right hand side, then semicolon. Similarly, we can say has delay, then variable, then equal, then expression, then semicolon. In this example, we initialize all signals to 0 at time 0 by writing this. And then we write has 5, A non-blocking 1, C non-blocking 1. As we introduce delay on left hand side, so it is our inter-assignment delay. It means wait for 5 time units and then assign A and C to 1. Note that A and C get updated at the end of the current time step. Then we write has 5 Q non-blocking A and B or C. Similarly, as we introduce delay on left hand side, so it is our inter-assignment delay. It means wait for 5 time units and then assign Q with whatever value RSS get and then evaluate. Then we write has 20. It means after execution the line wait for 20 time units. Next delay assignment is intra-assignment delay. In this case, delay is specified on the right hand side. The syntax for intra-assignment delay is left hand side, then equal, then has delay, then right hand side, then semicolon. Or we can say variable, then equal, then has delay, then expression, then semicolon. In this example, we initialize all signals to 0 at time 0 by writing this code. After this, we write has 5 A non-blocking 1, then C non-blocking 1. As we introduce delay on left hand side, so it is our inter-assignment delay. It means wait for 5 time units and then assign A and C to 1. Note that A and C gets updated after the end of the current time step. Then we write Q non-blocking has 5 A and B or C. As we introduce delay on right hand side, so this is our intra-assignment delay. What will happen for intra-assignment delay? It will first execute the statement and wait for 5 time units and then assign the value of the statement into Q. Then write has 20. It means after execution this line, the simulator will wait for 20 time units.